Alright, welcome back. This is the third and final video I'll be doing on closures. So, like I mentioned in my last video, I am going to be covering trailing closures as well as higher order functions. So sort, filter, map, and reduce. So let's jump on it. So trailing closures, what is that? Well, it's a closure. The thing is that if you need to pass a long closure expression as a function's like final parameter or argument, then instead of writing it inside the function, you write it after the function. So basically the closure is written after and outside of the function's parentheses. So best way to show you this is just to show you. So we're going to have some function here. So I'm going to just define function with closure, and it's going to have it in its parameters. It's going to take in a closure here. Okay, and we're going to say it's not going to take any parameters. This closure is not going to take any parameters, nor is it going to take nor is it going to have a return. It's just a closure. Okay, so bear with me. This is just a really simple example. And in here, we're going to have the function body. Okay. Now, without a trailing closure, when you try to implement this function, we usually do it with the following, where we have the parentheses and we actually just type in our closure inside. So here, you will have the closure body. Now with the trailing closure, instead of doing what we've been doing up here, we actually put it outside. So we're going to have function with closure, have our parentheses, but we're going to delete that and just have the parentheses there, and then have our closure follow right after. So in here, we will have the closure body here. Okay? So that's the basic syntax. It literally follows right after the function. Alright, so let's do a real example here. Alright, so I'm going to create a function that returns the sum of a set of numbers you give it. Okay, so it's going to, you have to set the starting number as well as the ending number, and then this function will do what it needs to do. It's also going to accept a closure in its parameters that will allow it to do more work, whatever we set the closure to be. All right, so let's go ahead and do function sum, then our parameters. So we're going to have a beginning number. This is going to be an integer. We're going to have an ending number, also going to be an integer. And then we're going to have our closure here. So I'm just going to do C for closure. And that closure is going to be, going to take an integer, and it's going to return an int. And then our function is going to return the final value. So the final sum. So it's also going to return an int. Okay. So let's go ahead and create basically our running total. So I'm going to do var running total equals 0. And then in order to add the sum for whatever our range, so beginning number to end number, I'm going to use a for in loop. So for in, so the beginning number to the ending number. And then what this is going to do is it's going to add, we're going to add the whatever the computation for the closure to the running total. So we're going to have a closure in, I. And then, let's see here. What is this saying? Written to but never read. Okay, so we need to return our running total. Hopefully that will make everything go away, and it does. All right, so basically what this does is it brings in our beginning number and our ending number, so whatever range we set it to. And it, for whatever number we bring in, so whether it's like 1 to 5, you bring in 1, it does the math here for our closure. I forgot to add a plus because we have to add it to the running total. And then it's going to add whatever computation that we set for the closure up here to our running total. And then we're going to return it. Okay? So the first thing I'm going to do is I'm going to test this out. So let's do the sum of the first 5 squares. All right. So we are going to pull up our function sum. I'm going to give it a beginning number, so we're going to do the first 5. So 1 to 5. And then here we would add our closure, but I'm not going to add it here. So I'm going to just delete this. And I'm actually going to add it to the end because we want this to be a trailing closure, right? Okay. So, I want this the square, right? So I'm going to do shorthand. So the first argument, which is going to be the first number, is basically going to be multiplied by itself. So $0 times $0. And we have it calculating 6 times. Let's go ahead and take a look. And we see our squares here. If I can get it to pop up. It's not working. Let's see. There we go. So 4 times 4 is 16, which is right. So we have 1, 2, 3, 4, 5. And if we assign this to a variable so we can actually see the sum. So sum, we did 5 square. If I call this variable, we'll see it equals 55, which is right. So if you add all the squares from 1 to 5, it does equal 55. Okay? So this part is trailing. So let's do one more example. So say if I just want the sum of, 1 through 10, just add 1, 2, 3, 4, 5 all the way to 10. We can definitely do that. So we do sum of first 10 numbers. So I'm going to do var sum of 10 numbers. So I'm going to equal this to sum. Again, we're going to do our beginning and end. So we're going to do 1 to 10. And we'll do our closure. All right, so how do you think this will, we're not going to do any computation, right? So we just want to pass in the first argument, right? So we'll just do $0, and it does it 11 times. So we're going to go ahead and take a look at that, and we'll see it equals 55. We also take a look at the actual graph here. So yeah, that's all right. So onward to higher order functions. So Swift provides several functions that take at least one function as an input, and here's a short list of them. There are more, and so let's go ahead and dive in, and I'll show you what I mean when I go through this. So sort, I've done quite a few examples with sort already, but I'll just go ahead and show you another example. So I believe above I did work with sort a little bit. So let's go ahead and create an array of names. And what we're going to do is we're going to sort these names alphabetically. So I'm just going to type in some names here. Okay. So you can type whatever names you want. I'm just typing in some random names. All right. So I have my list of random names that are not in any particular order. And so with sort, what we can do is we can tell, we could basically have sort names ascending. So we call, actually I should name it names, not name. All right. And we could just call the sort function right on it. Okay. And without any parameters, sort automatically assumes ascending. Okay. And I believe in the above I did descending with game scores. So let's go ahead and sort these as well. Descending, so from Z to A instead of A to Z. So we do descending names sort, and let's go ahead and use our trailing closures that we learned above. So we're going to take the first argument and it has to be greater than or start from Z and sort it that way. So it should be the opposite. So let's go ahead and pull up sort names descending. We see it definitely sorts from Z to A. Okay, so that's sort. So basically it takes closure to describe how the sorting is to be done. And that's how we want to do. All right, so map. So map basically transforms an array using a function. So it maps from one value to another. So it takes a closure expression as a single argument, and then it returns an alternate mapped value. It could be of the same type or a different type for that item in a new array. So from those new map values, it creates a whole entire new array based off of the array that you have brought in. All right, so an example of this, actually I'm going to create some space here. So my first example, which is actually kind of simple. So we're going to do I'm going to have numbers, so digit names. I'm going to create a dictionary. So I'm going to have 0 equals 0, 1 and 1, 2, 2, 3, 3. Right. So I have my dictionary from 0 to 3. You could go all the way to 9 if you want to, but I'm just stopping there. All right, and so now I have my array of numbers. So this is going to be 1, 2, 3, and 0. This is my array of numbers. Right, so what I want to do is I want to create a new array that will have the same order as my array here, but instead of having integers, it's going to actually be string. So I'm going to use this dictionary to map out my new array. Okay, so let's do name. So we're going to do number names. I'm going to equal this to numbers. And then we're going to map it out. So I'm going to do map. All right. So again, let's use trailing closure, since this is going to be kind of long. So let's create some space. So I'm going to bring in number. All right. And it's going to output a string. Do our in keyword. We do a variable here that will contain our output, and it's going to be a string, just an empty string. And then our output is going to equal our digit names, so our dictionary, and then whatever number comes in from our numbers array. And now I'm doing an optional here because I want to unwrap it, and then I'm going to add it to the output. And return it. Okay. As we see here, it's looped through each number in our numbers array, 1 to 0. So you have 1, 2, 3, and 0. And we've exchanged the number, the integer, for the string equivalent in our dictionary. So it's pretty nifty. Okay, so another example using map. Now, this example is assuming, I'm going to actually scroll up here, and I'm using Cocoa. So when I created this playground, I did it for OS 10. So make sure you have import Cocoa up here. If not, if you don't have that, oops, that's not what I wanted to output. If you don't have that, so when you create your playground, if you set it for OS 10 like I did, you go ahead and follow this example. If not, you have iOS, you can do this example. I'm trying to remember where I had, let's see here. Here we go, playground. So if you have import if you had your playground set up for iOS, so you have import UI kit, you do this a little bit differently. Okay, and I'll show you the difference. So I'm going to scroll back down here. All right, so what I'm going to do is I'm going to have some fun with color. All right. So I'm going to create a label. So I'm going to var my label. And this is going to, in Cocoa, for Cocoa programming, instead of UI label, it's NS text field. And so what I'm going to do is I'm actually going to create a frame in order to work with it inside of Playground. So we're going to do parentheses, frame, and I'm going to basically make a rectangle. So CG rec make, and I'm going to create the actual size of the rectangle for my text field or my label. So 0, 0, so that's the coordinates, and the size, which is going to be 250. All right. So when I pop this open, that's my text field. Okay. And now what I'm going to do is I'm actually going to create colors in this text field. So I'm going to create background color for it. For example, if I do my label background color, I can set it to a color. I'm going to actually set it to, let's see, NS color. I'm going to have it purple color. Now see, that's a lot of stuff to write for a color. I basically want to make this really simple. So what I'm going to do is I'm going to actually create a dictionary of colors. So I'm going to do color names, and I'm going to do red, and have that equal to NS color red. I'm going to do blue. Same deal, NS color blue. I'm going to go ahead and do my purple too. All right. And I'm actually going to create an array that contains color strings. So it's going to contain red, blue, and purple. Now what I want this array, what I'm going to do with this array is I'm going to map NS color, so this code here, into a new array, but it's going to be in the same order that I set here in my color strings array. Alright, so how would I do this? Well, let's create a new variable or constant, and this is going to be let colors. And I'm going to create a new array based off my color strings array. I'm going to use map in order to do so. Now I'm going to do a trailing closure because this is going to be quite long. So I'm going to bring in names, which are going to be string. So I'm going to call it string names. And it's going to output NS color. So this is the type it's going to output. I mean, this is a little different, but it's basically the same concept. So my output is of type NS color. Okay? Alright, so I want to kind of mimic what I did up here. So I'm going to do var output. But this is not going to be assigned to anything. I'm actually going to set the type, which is NS color, because that's what I want my output to be. Okay, and then I'm going to make output equal to the color name, so the dictionary I is referenced above, and I want it to pull the keys that is contained in string names. And I want to unwrap it. I want to force unwrap it. And then I want to return my output. Okay. So if we take a look here, we see that it's done some work here. Let's just pull colors since it's not pulling what I wanted to pull. And we see here that we have the RGBA colors for each. I know it doesn't look, it does look like a bunch of numbers and letters, but there are actually, it is actual colors for that we pulled in here. Alright, so now I want to change my label. So I'm going to do my label dot background color and have that equal to my new colors array. But this time I'm going to say I want it to be the first value. Oops, colors. Alright, so let's see. And it's red. And sure enough, here in my color strings, the first value is red. Alright, and I can do 1, which should be blue, and change this to blue. And then our third one, which is 2, change to purple. So there you go, fun times. Now, I did exactly the same thing, like I mentioned, with if you have your playground set up for iOS instead of OS 10, it is pretty similar, and I just kind of wanted to show you that you can do it. And here's my map version for iOS. So instead of NS text field for the other one, it's UI label for UI kit. And instead of NS color, it's UI color. So if you want to do it that way, you can. But basically, it works the same way. So I just want to make that clear that this won't work if you don't have the right library in. My library, again, is Cocoa. So just want to make that extremely clear. All right, so on to filter. So filter basically selects elements of an array that satisfies a certain condition. It's really similar to map, but basically it takes an instance of array type and it takes a closure as an argument in order to filter that array. So let's jump right on in. So I'm going to create an array here of I'm just going to go back to game scores. So I'm going to create another list of game scores. All right, so let's just add some random numbers here. Oops, I did exactly the same thing. Okay, and let's do one more. Okay, so here's my random list of game scores. And so with filter, let's just filter out something. Okay, so let's say we want to see all game scores that are above 1,000. All right, so let's do let scores greater than 1,000, and then we're going to take an array. So we do game scores list, filter, and our closure. Okay, so what we're going to do is filter takes in an integer and outputs a boolean. So that's exactly what we're going to do. So we do score int. So that, our scores coming in, or the arrays coming in, is of type int, and it's going to output a boolean in. And then we're going to do bar sorted. We're going to return, we're going to return our scores. So we are going to type in score is greater than 1,000. Oops, it would help if I put an equal sign there. Okay, so we see our list of scores that are above 1,000, which is awesome. Now we can shorten this again, or we can refactor this. So make some more space here. So let's refactor it. So we do, I'm just going to copy this name. I'm just going to type in refactor. So we do game score list dot filter. Now, if you remember our shorthand, we can use our $0 so that we're going to compare our first argument coming in and see if it's greater than 0. So we're going to completely do away with all of this, and it should output what we want it to output. So let's do score greater than 0 or greater than 1,000 refactor. And sure enough, it equals exactly the same as up here. And you notice instead of having this really long closure here, we've shortened it up using shorthand. Okay. So I'm going to do one more example, but this time let's combine sort with filter. So let's filter for the top 3 scores. I'm going to be using sort as well. So we're going to do let top 3 scores. And if you want to type this out or try to figure out by yourself, pause the video. Let's see if you can figure it out. Otherwise, if you're ready, I'm going to go ahead and continue on. So I'm going to bring in my list of game scores. So game scores list. And I'm going to do a filter like I did before. Do our closure. I'm going to do this in the long version. So again, I'm going to bring my scores in, which are type int. This is going to output a Boolean. So it's either going to be yes or no. One is meets the criteria. All right, and then I'm going to do bar sorted. So I'm going to create a variable here that is going to be equal to my game score list sorted. Now I don't want to do ascending. I want to do descending. So I'm going to do another closure in here. It's going to sort my scores descending. Okay, so now my scores are coming in descending. And then what I want it to do is I want it to return scores that are going to be, so the top 3. So because everything's sorted out, you can assume that the 4th, the score that is in place, or in the 3rd place, is going to be lower than the other 2 because I've already sorted, right? So I'm going to do greater than my sorted array, and the value at place 3, or the 4th place. Because if I pull this out here, I'll just go ahead and pull it out. And look at sorted, you'll see that this is sorted from the largest score to the highest score to the smallest score. So what I'm doing is I'm saying, since I know that the value at 4 is going to be lower than this 3rd and 2nd and the 1st, then anything greater than 700, which in this case is 700, is going to output. And that's what I did. Now, there might be an easier way to do this. And that's just one of the ways I decided to do it. So hopefully that's helpful as to why I did it that way. Okay. So, fun times. Okay, so the next thing I'm going to do is reduce. So with reduce, basically it combines the value of an array into a single value. Okay, so the best way to show you this is just to show you. So I'm going to create an array here. Let's have words. And because I'm silly, I'm just going to put this. So Swift 2 is flippin' fun with Johnny. Because I'm silly. Alright. So I have my list of words. Now what I want to do is I want to take this array of words and make it into a string that looks like a sentence. Okay, so I can do this with reduce. So I'm going to create a variable here. It's going to be sentence. I'm going to bring in my words array. I'm going to do reduce. And this is going to be basically a string. So I'm going to state, okay, there's going to be a string coming in. And now I want it to look at each item in the array. And then if it contains a string, if it contains something, then it's going to change the format. So I'm going to do if, I'm going to do shorthand here. So if the first argument comes in, if it equals nothing, so it has nothing in it, I just want you to return the next one. So return the second argument. I don't want you to do anything. But if it actually contains something, what I want it to do is have a new format. So I want to have the word come in, then I want it to concatenate to a space, and then also concatenate it to the next value. That makes sense. Okay. So what it should have done is it should have looked at Swift and seen, okay, there is Swift there. Therefore, I'm going to return that. I'm going to look at the second one and say, does this equal this? And then I'll just keep going on from there. And then if I look at sentence, this should output the string, which it does. Okay. So that is reduce. Now, I'm going to do one more example of reduce, just so that it makes sense, and just because of practice is always good. So what I'm going to do is I'm going to find the largest number, or largest score, or actually I should say highest score from the score array above. So I'm going to do let max score equal game score list, and I'm going to say reduce, and I want it to start at the first value. So start at 0, so the initial value. So I'm going to do game score at 0, so you start at the first element in that array. And then what I want you to do is to compare it to every other value and output the one that is the highest. And I'm going to do this in really shorthand. So I'm going to do if the first value is greater than the second value, then I want you to output the first value. Otherwise, output the second value. Okay. Okay, I've got a wonderful error. What did I do wrong? Oops. Game score list. That's what I'm supposed to do. Nope. Did I make a mistake here? Okay, I did. Alright, so if we look at max score, it should be like the 12,001. Alright, now I know this this is kind of funky and I had to actually look this up. So if you hold down the Option key, your little pointer will turn to a plus, hover over reduce, click on it. We can actually look at reduce. So reduce is a sequence type. So if we scroll up to reduce, let's just see if we can find it in here. So reduce combined. So basically it is a type that can be iterated with a for in loop. So basically it does this in iteration. See if I can try to find it real quick. Scrolling up, starts with split. So you see there's many higher order functions. That's what I was saying. There's our sort. So our sort is an array. It returns an array containing assorted elements of source according to is ordered before. So here's the declaration. With reduce, so what it does is it returns a result of repeatedly calling combine with accumulated value initialized to initial and each element of self in turn. So when I said for it to start at 0, it's basically saying I'm initializing it to start at the first value. So that's why it's a little odd, especially with up here. I'm like, okay, well, why'd you do this notation? Because I'm telling it to start at the beginning. Same thing with this array. I'm telling it to start at 0, so the first element. All right, so that's that. So if you want to end this video, you can, but I'm going to go into a little bit more detail and show you some more examples because I think it's helpful to have more examples, and I really wanted to kind of have fun with this and to really dive in there. And if you want to, you can join me. Alright, so what I'm going to do is I'm going to find all the sums of squares for all the odd numbers of an array of numbers, and then print it out using map, reduce, and filter. So I'm going to try to use all 3 of those to find the sum of squares. Okay, so I'll create some space here. And then I'm going to refactor, and then refactor again using shorthand parameter names. Okay, so let's go ahead and I'm going to create an array. So I'm going to create an array. I'm just going to call it some numbers. And then I'm going to just type in some numbers here that I can use. Let's do 30, 19, 23, and 12. Why not? Okay, so I believe I have some odd numbers in there. So if you want to try figuring this out for yourself, again, definitely pause this video and try to work through this using map, reduce, and filter. Now, when I have a problem such as this, it's just really best to start really small and think of what the first step would be. Well, first of all, I believe I want to filter out all the numbers that are odd, because I think that's going to be the best way to work with this. So I'm going to create a new array. So I'm going to do var filtered numbers. Let's do filter num. Actually, let's do numbers shortened. So I'm going to take in my numbers array. Actually, I'm going to rename this. So I think it's a little bit better if I do like numbers. Do just numbers. There we go. Shortened. Alright, so I'm going to take in my numbers array and I'm going to filter them. And I'm going to do my trailing closure, and I want to have it bring in an int. So the numbers are coming in are all integers, and then it's going to output a boolean. Do in, and what's going to return is whether they're odd or even. And the way to do that is to use modulus 2. So if 2 is divided by the number, if it's even, the remainder should be 0. If it's not even, then it's odd. So I'm going to say if the number modulus 2 is not equal to 0, then that's what I want it to return, because I want to bring out all the odd numbers. And sure enough, we have all of our odd numbers from our array. Then the next thing I want to do, I want to get the square of my odd numbers. So I'm going to go ahead and remap my numbers, because I want to get the squares of my filtered numbers. So I'm going to do map numbers, and I'm going to bring in my filtered numbers. Do map, and again I'm going to do my trailing closure. And now I want to, it's going to bring in a number, and it's going to return an int. So we do number, return an integer, in, and then I want it to return the square. So it's going to be number times number. And that should create my new array of squared odd numbers. So here's my original filter numbers, 3, 5, 9, etc. 3 times 3 is 9, 5 times 5 is 25, so on and so forth. Now the next thing I want to do is I want to create the sum. So I want it to add all of my squared numbers. So let's go ahead and do var reduced numbers, and this time I want to take in my map numbers that I did up here, and I want to combine them all. So I'm going to reduce, I want you to start at 0 and delete all of this and do my closure. And then here, I want to say, okay, bring in 2 numbers as my parameters. So, or bring in 2 parameters, both of type int. Now I want you to return an int, which will be our sum, in. We'll do return. Now again, the sum is what? I plus j. And that is 1005. And if you do this math up here, you will see it does most likely equal that. I'm pretty sure it does. Okay, so let's refactor this. Now, what I want to do is I want to start from up here and just do the filter. Actually, I want to start from up here, the filter numbers, but not have all these extra variables. So let's go ahead and do let sum equal. I'm going to start at numbers. So I'm bringing in my original array up here, down here. And then I'm going to do filter. So I'm going to do my filter first. Okay. And then I want to, after my filter, I want to do my map. And again, do our closure. And then after my map, I want to do reduce. So I'll just type in reduce. And with reduce, I want to make sure that I bring in, initialize it first, and then it will also have its closure. And I'm going to actually break this up a little bit so it's a little bit cleaner. Okay, so my filter. What was my original filter? Well, it was originally num int. So I'm copying it from above. And it's going to return boolean in, and it's going to return my number modulus 2 not equal to 0. And then my map up here, I have a number coming in, and it's going to return an int in, and it's going to return the number times itself. And then my reduce takes in two numbers, or two parameters of type int, and then returns an int, so the sum, in, and then return I plus j. Alright, and then if we call sum, we'll see that it equals the 1005 that we had up here. Now we can refactor this again, which is just crazy. So this time I'll go ahead and do the shorthand parameter names. So I'm going to do let shorthand sum equal, I'm going to bring in my numbers array, do filter, trailing closure. I'm going to do the first parameter, or the first value modulus 2 and not equal to 0. And return, do map. And with map, we multiplied it by itself, so 0 times 0, and then I did reduce, initial at 0, and then add the first to the second. Okay. So if we call our short hand sum, it should equal 1005. So there we go. I covered quite a bit in this video. If you stayed with me the whole entire time, awesome. You are awesome. But basically, I covered quite a bit. I covered trailing closures, the syntax, some examples, and then I covered higher order functions, so sort, map, reduce, and filter, as well as some extensive examples combining a lot of them together. So hopefully you found this fun. Hopefully it was helpful to you. If it was extremely helpful, please like my video. If you like all my videos, awesome. Please subscribe. And till next time.